And here's what's going to happen at the end of this lesson. We're going to have a better idea and an understanding that is a set of data collected to answer a statistical question has a distribution. Now, have you ever heard of a distribution center as far as shipments goes? For example, I'm always ordering stuff off of Amazon because I think it's fun and also it's very affordable. There's distribution centers, and sometimes it'll be 30 hours after I order something and it'll be here because a distribution center is close. Okay, I think there's one in Kentucky, and then there's going to be one in Illinois in the next 5 years, which means that we'll be paying tax. But can anybody describe to me the word distribution, what you think that word means? Now, when I say what you think that word means, that means that there's no wrong answer here because it's what you think. You may know what it is, or you may have never seen that word before, and that's fine. Yeah, Eminem?
I think it's when you distribute something, which is
Okay, so you said distribute, give, right? Okay, good. Give something, good. You have something to add to that? Pass something out. When you're passing something out, when you're giving something out, you're distributing it. Good. And you've also seen the distributive property of multiplication, right? Good. So we have distribution. We have an idea of it, right? Good. Which can be described as by its center, spread, and overall shape. Vocabulary, distribution. As the arrangement of the values, let's get the whiz teach out of there. Go away. There. Arrangement of the values of a data set. So yesterday we had data sets of numbers that we were finding the mean, median, and range and mode. So spread, and we look at the data sets to determine the distribution. We'll get into that more. Center. Graphically, so on a graphic, the center of the distribution is the point where about half of the observations are on either side. So this class, there's more. Is there more girls or boys in here? Excuse me. So as far as if we were to find, like, if we were to have all the girls stand in a single line and then all the boys stand in that same line on the other end, would the center of it have girls or boys? Girls, because there's more girls. Good. Spread. The spread of a distribution refers to the variability of the data. If the observations cover a wide range, the spread is larger. If the observations are clustered around a single value, the spread is smaller. For example, if we were taking data on grade level at this whole school, the population of the grade level, would there be a whole lot of variability? Would it vary much? And I'm not saying vary as V-E-R-Y. I'm saying V-A-R-Y, as in it's different. How much would it vary? 3, 6th, 7th, and 8th grade. Now, what if we had a family reunion? Okay, there's a family reunion. How much would the age groups vary there at a family reunion? A lot more. Okay, the age groups would vary a lot more. Good. More vocabulary. Shape. Shape of the data is described by its skewness or its symmetry. Symmetry, symmetrical. Do you guys have art in 6th grade?
Yeah.
Do you guys talk about symmetry at all?
Yeah.
Cool. Along with the number of peaks or gaps. And now this is just introducing this stuff, so we'll see it more later. And also this will be online, so if you guys want to see this PowerPoint, you can get that from there too. Along with the number of peaks or gaps. Symmetry. Data can be divided at the center so that each half is a mirror image of the other. Okay, that would be, well, I'm introducing these, we'll have examples here in a little bit. So that would be symmetrical symmetry. Skewness, having more observations on one side than the other. Distributions with most of their observations on the left toward the lower values are said to be skewed right. So the lower part is the skew. So you'd say skew right if it looked like, here, let's, enough of describing it, I'm going to show you. So if I had some data, it was blah, blah 2, blah 3, okay? And if I had my data sets that were like this one would be skewed right. Because this part here is the lower part. Most of the data sets are going to be in this spot here around blah 1 and blah 2. Yep, blah 1 and blah 2. Yes. Blah 2 was bigger than blah 3 because it's a skewed right. Said to be skewed. Oh, and then what's the other way? It's skewed left. Unusual features. That was my nickname in high school. Refer to gaps. What? Refer to gaps in areas of the distribution where there are no observations and outliers. So it's not anything that's consistent. Line plots to describe data. This is what we're going to be doing after this is done. So the number of sit-ups in a minute. That is how many people can do sit-ups in a minute. A friend of mine, she did, when she was going for the police academy, she was able to do, one time she did 51 sit-ups in a minute. Yeah, she's a beast. It's also a 30-year-old woman. So that's how many people can do. That's how many people can do 20 sit-ups in a minute. Okay? So how many people can do 20 sit-ups in a minute? Someone raise your hand. How many people in that group can do 20 sit-ups? How many is it? How many is it? 7. 1, 2, 3, 4, 5, 6, 7. Yeah, there's 7 people who can do 20 sit-ups in a minute. Now, the center of it. So let's see. The center of it, let's see how many data sets we have. How many data sets we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We had 7 there, 19, 20, 21, 22, 23, 24. So in order to find the center, does anyone remember what the center said? What was it about the center? Okay, I see what you're saying. You're confusing it with the median. The center is, from the vocab that we just had a second ago, or a minute ago, was talking about we have all the data sets on either side of it. And since we just counted 24, we need to see where there's 12 and see where the center is. So we have, we need to see where the center is by counting 12. So we have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's our center. Okay? That's where it's all the data sets on the left and all the data sets on the right. Now, is the spread, are we symmetrical? Are we skewed to the left? Are we skewed to the right? I say there's a slight skew to the left because there's only one person who has 16, but 2 people have 22. So it goes down from 3, 2 to 1, where on the right it goes from 3 to 2. So our shape is going to be skewed to the left. Our spread is going to be from 16 to 22. So it's a pretty decent amount, but it's observable. Let's see, are they going to give us answers? No. Looks like I have to do this. Yes, ma'am.
I don't know why, but like I've never understood line plots.
No? Well, we're going to get some practice today. I'm glad you say that. So now we're going to be able to understand it. Students said, I don't know why, but I've never understood line plots. We're going to be able to do it today. So histogram to describe the data. So we have number of students who have a final score of that. Now I could do our last test score, but I don't want to advertise how many people did poorly compared to well, so we'll just pass on that one. Maybe we could do something else right now. You know what? Yeah, that would take if I did, I'm trying to think of ones like we could do cats or dogs, but that's not enough data sets. Or birds. Okay, sorry, I'm just spitballing here. Coming back. So we have our center. So how many kids took this? Quiet, please. We had 13 with the green. So 13, so we'll just go 1, 3, 4, 6, 12, 21, 34. It's a lot of kids. 34 and 39. So there's 39 kids that took this this final score. Okay, so it must be a high school class or maybe with 39 kids in it. And our center is going to be where there is, maybe there might be 20. Yeah, where there might be 20 on either side, so that would be the center. The center would be where there's 20 on the right. So we have 6 and 13, or 5 and 13, so it's 18. So our center is going to be somewhere around here. Actually, a little bit closer to there, because that would be our center of where all the data is, because we have 40 kids. So that's definitely skewed to the left. Do you agree that that's skewed to the left?
Yes.
Okay. And our spread is from doing as horrible as 20% to 100%. Wrong button. Box and Whiskers. This is the one that always got me as a kid. Now this one shows where the median is, and it shows where the outliers are. See the upper extreme and the lower extreme? And to the extreme, rock the mic like a vandal. That's Vanilla Ice. And to describe the data, the lower extreme, that one really demonstrates where there's an outlier. Like if someone was not feeling well, or they just got no sleep because they just weren't feeling well last night, and they did really, 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 really poorly on a test. That shows that there's an outlier there. Okay? Let's see. How long before he notices that I'm not talking? There it is. Hi. Welcome back. So it shows us the median, shows the upper quartile, the lower quartile. Notice how there is, where are we? Yeah. Notice how there's only 3 values between these 2 spots here, but there is 11 values between those 2 spots. That's the difference of where the people are scoring. Okay, that shows where people are scoring with the quartile, above the median, below the median, because you know that the median is going to be the average score of all those points, but the quartile is going to represent how many people are in that small spot. So there's just as many people that scored between the median and upper quartile as there were that were in the median and lower quartile. Okay? Value is going to be held higher. Wrong button. Okay. Okay, thanks. I think it's mine. No. Yep, it is. It's for my allergy shot. All right, line plot to describe the data. Number of families with one or more one or more children. So, number of families with one or more children. We could do that. That's something we could do. Whoa, okay, hey, all right. So the center, there is 3, 6, 9, 12, 15, 18, 21, 22, 23, 24 data sets there. Okay? And it would be, the middle would be, or the center would be 10 to the left and 10 to the right. So we got 3, 6, 7, 8, 9, 10. So the center is going to be on that 3. The spread is going to be from 1 to 10, and there's an outlier of 10, but the spread is going to be between 1 and 6. That's what typically people have. And the shape is going to be, is that skewed left or skewed right? Because I can't remember. Does skewed mean the high part or the small part? Small part. It's skewed to the right. It's skewed to the right. In closing, look at the following chart. Describe the data by its center, spread, and shape. So let's first off, I'll do you a favor by counting for you. We have 1, 2, 3, 4, 5, 6, 7. Okay, so we had 21. So let's look at that. Can someone describe the center? Where is the center? Yes. Number 8. So we're going to be at the 8. Now, that would not be the center. That's the center of the age on the graph. Let's look back at what the center is. Let's look back at what the center is. Center is the graphically, the center of the distribution is the point where about half the observations are on either side of that. Okay? And the spread is cover a wide range or clustered. Okay? Okay. Who haven't I heard? No, Brooke? Is it 5? So let's see. That would mean that there'd be about 10 to the left and 10 to the right of 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. 5 is going to be your center. Good. How about its spread? Do we need to go back to the spread? Spread. The spread of distribution refers to the variability of the data. If the observations cover a wide range, the spread is larger. If the observations are clustered in a single value, the spread is smaller. So, is this guy clustered or spread? Now, think about this, though. What if we were talking about the age groups of everyone in this building? Would that be more spread or clustered? Okay, now here's the thing. There's about 50, 60 employees in this building that are not students, maybe, I think. I think I counted them one time. Well, let's see here. No, it's a lot more than that. 9, 10, 20, 30, 40, 50, 60, 70. Okay, so probably about 90. So there's about 90 of us here that are adults. So if everyone's included there, and there's about 900 or 800 students in the school, 800 students in the school, so that would be pretty clustered around the age groups of 10 to 14. So that one would be a little bit more spread, but this one's pretty clustered because it's all just about everyone from 1 to 7. Yeah. This isn't a middle school. I'll show you an example. Okay. Now let's use this black background for making our own stuff. All right, so we're gonna do a line plot for birth month. All right, so I'm gonna move this a little bit so I can move around a bit. Okay, so I'm going to start on the right side. So we'll do, what color should we, let's make it nice and colorful. All right, so I'm going to start at that table. I'm going to go around. It's going to go there. And then here, we're going to do this quickly. Okay, I'm going to try to do this quickly. So Taylor, what month were you born? April. Okay. June. Okay. Uh-oh. USA? May. Yes. Okay. Skylar? Oh, wait. Did I get you yet? Okay. Skylar? Middleton? July. Okay. June. Rebecca? September. Uh-oh. August. March. All right, and I'm in the classroom as well, so I'm going with August. So now we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25. There's 25. So find the middle. Can someone remind me as a review, to find the middle, what do we need to do? Yeah. Or the center. Sorry, the center.
You kind of make it where both, like, there's the same number on each side.
About the same number on each side. Now, is this clustered or is this spread? What's the... It's very spread. It's pretty spread. Yep. Okay, so it's pretty spread. Is it skewed left or skewed right? If anything, it's almost skewed right, but that's only because we have no Octobers and we have only one November and one December. So we have the shape is going to be whether it is skewed left or skewed right. So yeah, it's going to be the opposite, whatever's not tall. Quiet, please, boys. And the center, since we had 25, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's going to be about June, July. June, July. Then our spread is going to be, wait, not the spread. That's not the word I'm looking for. Yeah. So the spread is either going to be clustered or wide range. That's what it is. Hey, let's easy. So spread is wide range. So I'm going to save this picture. Whoop. Okay. Very good. Are there any questions about the line plots? All right. So, dun 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 dun. Is it going? Oh, I thought that was not saving.
Did you hear a dactyl noise?
No, don't.